group is Jude, Arturas, and Ansel and Cosmin. Our project was to build a robot with Lego Mindstorm. This is the final result. I hope it works. Okay, Arturas is going to talk about the requirements of the project.
Like Cosmin said already, that we had to build robots on the Lego Mindstorm, which had actually to supposed to transport something somewhere. The car has able to receive and respond the signals and react to it. In short, the car have to communicate. Car have to respect and follow the system rules. The vehicle have stop in different points for different time limits as well. And car have to avoid the contacts with the other cars, like acting in the real road with the real traffic. So we had to use ultrasonic sensor to avoid the accidents. So this is our requirements and goals.
Okay, we move on to the key technologies that have been used to build our robot. And what you can see here, we use a color sensor. There are two types of color sensor in the package. So we use the high-tech color sensor for that. We use one piece of it, and we use one piece of the ultrasonic sensor in front, because since there was only one-way traffic, we have to move in front, no movement behind. So that's why we have just one piece in front. There's no need to put behind, because other cars are going to sense us and stop. And then we use two pieces of the light sensors. And then the servo motors also, we use two for the two main wheels, even though we had another wheel behind. So altogether we had three sets of wheels.
Three sets of wheels or sensors?
Wheels.
Wheels, okay,
Wheels.
yeah.
Yeah. So the design structure, what we used to build our robot, we have the NXT brick, which is the main brain of the whole stuff, where the programming and the control and everything has to be done. And we use, that's just a picture of the servo motor, how it looks, and ultrasonic sensor, which I already mentioned. And then this is a picture to show how it looks. The front view of it, everything. We see the high-tech color sensor, which is going to detect some colors that are out of the track. Yeah, because we have a black track that has to follow. The two sensors there are just to, not to sense black, but to sense out of the black, white. If both are white, then it means it is on the track. So that's why we have this, the space in between them. Yeah. And then how does it look underneath? This is how it looks on the other side of it, and that's it. And we're going to know before that. I just explain a little bit why we have to use this tool again. For instance, if we have the right light sensor, if it senses black, it therefore means that the robot is already going out of the track. If it senses, if the right senses black, then we have to make an adjustment. The left wheel has to go faster than the right wheel for it to adjust back to follow the track. And the same thing happens, or the opposite of it happens, when the left sensor is sensing black. Then we have an adjustment such that the right wheel moves faster than the left wheel, so that it goes back to the track. And then we have three main colors that we use. We have a blue for turning, and then we have red for factory A and B for stopping at the 3 seconds and 4 seconds respectively, factory A and B and C. And then factory C, it has to stop for 6 seconds, to offload, something like that. And I think that is it.
Yeah, I'm going to show you the program real quick. And this is how the program looks. It's not so complicated, but to help you guys, I'm just going to break it down in a flowchart. So basically, yep. So we have the program start, and after that we check the value of the Bluetooth, like we make a communication all the three trucks. And basically what we get from the Bluetooth from the mailbox is either number 2 or number 1. And the way we did it is if we get a number 2, if it's number 2, then we run 2 different programs. Basically this is the route to A to C, and this is B to C. And if it's 2, it runs to B to C, and if there is no response, actually it doesn't start.
Mm-hmm.
And I'm going to show you the 2 programs. Actually, this is the program that we're using.
Mm-hmm.
And we have first we check the value of Bluetooth standing sensor. So if it's less than 20 centimeters, it stops. If it's not, it continues. And here we have our high-tech color sensor. And what we did actually is we're taking the value of the high-tech color sensor, and we have 5 different statements.
Mm-hmm.
Basically, we did a small program. This is the program that we actually did and tried, and actually takes the value, turn it into a text, and put it on the display. So this way we are able to say, okay, 2 is blue, 9 is green, and actually there's a mistake here, so it should be 4. It should be 4 and 6. And this is the default value, and this is the value that will always turn, always run.
Yeah.
And this is basically our light following, and as Jude explained, the light sensor detects light, it detects the second light sensor. If it detects light also, that means that we're on track. And if it doesn't, it has to make little calibrations, like small turns. And if the bolt sensor does not detect light, it should stop, but we had some problems with that, so now we made it to run at full speed. We have some problems with that, but we're going to explain it later. And pretty much this is the same as the previous one, except that we have different timings for C. This is A, and this is the starting point where it actually terminates the program and it shuts it down. Because when we have to start a program to get a new number from the Bluetooth, basically. And yeah, this is the blue. We're using it for the right turn, and we have to adjust a little bit in we have a blue marker and have to adjust a little bit so we can take the turn. We can go straight forward.
You're at 7 minutes.
Yep.
The problems that we met. We had a problem with the camera. We tried to use the camera from the Mindstorm. We program it, we kind of understand how to use it, but after that we quit because we decided that maybe it's not enough time and that's not gonna work. And
What did you want to use it for?
to track the colors
Okay.
Line track.
and the line, because that will work faster. We have a problem with the motors. One of them was not working. After we started using the sensors, we're trying, the robot was not working, and we didn't know what to do, and after that we tried to change the motor, and we see that that was the problem. And with the design, we designed the robot like few times. We had the problem which with this wheel, the third one, but yeah, now it's working, we fixed it. And yeah, the main problem was with the line tracking. It was always going right, after that doing something else. I don't know, when
Yeah,
you're tracking the color, it was going away
Okay.
without setting it. We set it just to go straight, follow the line, and sometimes when it was the blue color on the line, he was just going
Yeah.
all directions or something. He was coming back, so we worked a little bit on that. And now it works.
Okay.
We have also a video.
Yeah, but before that, we just
Yes.
say why do we recommend our stuff? Yeah, it's really flexible. Also, we have a small attachment behind if there is changes in the future for any load carrying,
Yeah.
even though it was not required. But we have it on one of our videos, attach something to pull the load. It's easy to do that, it's flexible, adaptable, it's very stable, it's safe. Also because of the ultrasonic sensor, it actually stops when there's an obstacle in front of it.
And at the end, we would like to thank you, Andrew, for the great supervision. We would like to thank Jonas, because he helped us with the camera even though he didn't use it. And we also like to help to thank our colleagues because we had some problems and we asked them and they helped us, and that's why. So thank you, guys. If you have any questions, of course, you can ask.
This is
It's easy to attach.
yeah, we can attach.
Is there a real quick video, or
Yes,
Yeah.
if you want, we have video.
if it's just really quick?
Okay, this video is moving from factory A to C.
There is
And
blue color.
this is a blue color. Actually, it could have made a turn if it was going to factory B, but
Mhm.
this is intended for A. That's why it ignores the color.
And yeah, this is like a testing, so we can see that it didn't exactly hit the color, so it didn't stop. So that was like an early video that we made.
And the reason for that is because the distance from the line to our sensor, the colors that we had there, they were not, at the same distance.
Yeah.
So the sensor could not reach the color.
Mhm.
But later we had to stretch them out, so now it works.
No.
It's
Yes.
Did you increase the speed on this? to
Yeah.
see how
Yeah,
fast
we
it
could
was?
increase the speed of
Yeah.
this. I think video to show.
I think we're gonna have to stop now,
Okay.
so we can get to the next
Yeah.
one. We have some comments from your group. Yeah,
The
maybe?
video was nice.
Yeah.
So it showed up there, so we could all see it.
I have a comment on the work process because we've been sitting beside them all the time, and I think they've made an impressive finishing sprint here at the end, really making a good product.
Well, we lost a lot of time on the design because we changed a lot of sensors. Then we decided to use 2 light sensors instead of 1, and at the end we figured out that it's probably the design because this wheel was in front, and those 2 wheels were dependent on this one. So when we made the turns, kind of like it was not accurate as it is now.
Yeah, we have the documentation of almost everything that we did because he said that we had to change the design. We have pictures of the old model that we had. We even have pictures to show the problems that we had with the wheels and all of that. Yeah. Instead of having the third wheel in front of at the front of at the front of it, we had it behind, and it was very hard for it to track the line.
I'm going to have to cut you off here and see. Do we have some other comments or on the presentation? Then I'll start out like I normally start out. I think overall, really good presentation. Cosme Natsuas, you guys need to get more involved in this. The majority of the time was with Jude and with Ansa, and if this was like a group presentation, group evaluation, then you guys don't get enough chance to really come in and say something or talk about it, about some of the more technical issues. So you need to come more and be more involved in the presentation. When you talk about things like the problems met with the camera, make sure you tell us what those problems are. So don't just list a bullet point up there like camera was a problem, light sensor, and be specific. Use specific terminology on it.
We managed to make it to track the colors, to track the line. And
Oh,
Yeah.
there was disagreement.
Yeah, and that's actually something that I've noted here that I wouldn't want it in the presentation, but I would like to know, how did you actually? That's something an interesting issue to take up because you have 2 competing designs. You could do the light sensor, you could do the camera sensor. That was one of the issues that you had because we talked about that with loyalty in the group. That
Yes.
as soon as we say, no, we're not going that way, then we have to make sure that we all focus on.
So that's why we
Yeah.
quit
Yeah.
using the camera, because
Yeah.
you told us and we were thinking like, okay, we work too much for the camera.
Yeah,
So, yeah.
I really like, well, when we had the requirements, you know, too much, right? Too much, yeah. We have to filter ourselves, small presentations. So which are the important requirements, or which are the requirements that we're going to come in and talk about during the presentation? So maybe there are 2 or 3 driving requirements that we want to say, but we saw these as the main requirements for the project, and we're going to come in and talk about how we actually address those, or how we really achieved a good design on the system. I think Jude was a good introduction to the different mechanics there, but you got a little bit lost with the requirements, then has to stop at the factory, start at the factory. It got a little unprecise at that point in the presentation. So it was overall a good presentation on it, but maybe scripted a bit more, or maybe a bit more structure in what you're showing. I really like the flow charts. I don't know how the rest of you felt about those flow charts.
Yeah.
Doesn't that help you understand
Yeah.
more than the just looking at the code
Yeah.
going through? But have you programmed before? On, so you.
Yeah.
So this is you've done those types of diagrams before.
Yeah.
It looks like it, and worked on those. And that's really going to help you when you start doing programming with Peter there to look at some of these to see. This lets me know how the program is supposed to be working and how the whole structure is, and then the implementation is how I do it inside of the Lego. So it's a really good job on that one. I got lost in them though. I didn't know what the difference was between the first and the second one. So put a header
Talk
on.
about the difference.
Put a header on the slides that I can remember exactly where I'm at on those different slides. But otherwise, good job, and I look forward to seeing that demonstration.